welcome to the physics class. Today we are going to deal the very important topic for the 8th class students. Okay, so we have discussed about that 1D motion and the related problems. Now it is time to look into the matter of the previous competitive examination problems. It's very clear? Yes. Okay, you have to get 1D motion examination problems which are given in the previous competitive, right? Very clear. So we would like to go for that. If you are going to talk about that 1D motion, what you are going to look, the motion of your body has been restricted to move along one direction. It's very clear. Okay, let's see how it is going to move that. Yes, it's very clear. Yeah, we would like to go for that. Yes, along 1D, just either it may be along x-axis or along y-axis. It's very clear. You would like to go for that. Yes, so 1D motion, just you have to confirm. All right. Okay, you have to take this. Yes, we would like to go for that. When it is going to be allowed to fall down due to the Earth's gravitation power, just we have to see. It's going to be find out. Okay, with the external force, just we have to see. This is going to be fall down due to the. Yes, you have to confirm this one. It's very clear. Now, if you are going to get that due to the external force, what happened? Just you have to see. Just you have to see. Due to the external force, it is going to be having its own velocity. That is going to be initial velocity and the final velocity. It's very clear. It's very clear. Yes, you have to take this one. So, while you are going to fall down, when it is allowed to fall down, it's going to be having the consideration of acceleration due to gravity. It's very clear. Okay, right. This is going to be identified. 8th. Yeah. Yes, you can confirm that S is equal to ut. We would like to use the formulas half at square. It's very clear. All right, it's very easy for you. Just you have to take that u is the initial velocity. It's very clear. Yes, you have to consider t is the time. All right, it's very clear. Now we would like to go further. If it has been started from the rest, you have to consider u is equal to 0. Yeah, if it has been started from rest, yes, we have to consider u is equal to 0. All right. Now, we would like to go further. At the time, we have to take that s is equal to 0 plus 1 by 2 at square. All right, this is very clear. Okay, if it is going to be having that initial velocity and final velocity, it is going to be in the motion. So, due to the external force, there exists a change in its speed or velocity along one direction. It's going to be the same, no doubt at all. Due to the external force, what happened? There exists a change in its speed. All right, so it causes to that acceleration. Acceleration possessed by that body is going to be identified. Again, we can use that. It's going to be v square minus u square is equal to 2as. This is very clear. This is also one equation of motion which is going to be identified. In case of uniform motion, just we have to consider. All right, it's very clear. Yes, you have to take this one. In t simultaneously you have to take that. It's very clear, very clear. Yes, if you are identifying that t is equal to 1 second, all right, t is equal to 2 second, t is equal to 3 second. Yes, in the different time intervals it has been covered the distance, you have to confirm, it's very clear, all right. Now we would like to go for this one, this is going to be here, all right. We would like to go for that, this is going to be another distance, all right. Yes, you have to take this one, yeah, this is going to be, yes, you have to take that. So in this is going to be H2, yeah, just you have to take care about representation, all right. In 1 second it is going to be having vertical distance, it's going to be having that vertical displacement, no doubt at all, in 1 second. At the same time, if you are going to take that time, that does it increases, time is going to be 2 seconds, let us assume. It covers the distance, it is very clear, time is 3 seconds, it is going to be identified. Alright, we would like to go for this one. Okay, easily you will solve the problem, yeah. You will take that in one, just you have to take that first second, in 1 second it is going to be identified that as is equal to 1 by 2. If it has been started from that 1 square, it's very clear, in 1 by 2 a into 2 square, like that we have to take, this is the first one, this is the second one, this is at t is equal to 1 second. In this way we can solve the problems, it's very clear. So we have to consider a is equal to 0, a is equal to g, that's very clear, it is going to be in the direction of Earth's gravity, all right. So yeah, it has been moved in this direction, yes, it is going to be considered, all right. All right, we have to take this one, whether it is going to be having the motion in this direction, just you have to see, this is very clear. You would like to solve the problem, easily you can solve that, it's very clear, right. Yes, we have to go for the problems related to this concept, just we can see. Yes, you can look into that matter, it's very clear. You would like to solve for the distance travelled, what they are going to ask that. Yeah, distance travelled by the particle starting from rest and moving with an acceleration of 4 by 3 meter per second square. In the third second is, in the third second the distance travelled by a particle, just you have to see, this is very clear in the third. If you are going to get that, this is going to be the third second, how you will calculate in that? You should take that in t is equal to 2 seconds, in t is equal to 3 seconds, you have to get the subtraction, just you have to confirm. In the third second, let us assume this is going to be this one. How you will get that in the third second? If you are going to get this one, it's very clear. You would like to go for that, to solve this problem, you have to take here. I am going to take that, this S2 minus, yeah, S3 minus S2, it's very clear. This is going to be, that is, it gives the distance covered in the third second, it's very clear. And you may find out that speed and acceleration simultaneously, it's very clear. So as the time increases, what happened? Distance, vertical, it's going to be, the vertical displacement is going to be increases, it's very clear. Time increases, distance covered by that body is going to be increases, it's never be decreases, alright. So you have to find out that in the particular interval, of the time, in this particular interval, in this interval, you have to find out that. So there is a case we have to take. Yeah, the distance travelled by the particle starting from the rest, it is very clear, and moving with an acceleration in the third second, it is going to be in the third second, right. So easily you will solve the problem. T is equal to third second, we have to take that. Yes. Yeah, starting from the rest. What you can write down, that is going to be u is equal to 0, alright, u is equal to 0, alright, okay. And they have given the acceleration, yes, it's very clear, that is going to be a, that is equal to 4/3 meter per second square. It's very clear, you would like to go for this one. Okay, what you have to find out that distance travelled by the particle in the third second, how it is getting that. Okay, you have to take this one. Yeah, distance travelled by the particle is in the third second. Third second is equal to, you have to find out that, yes, that's going to be 1/2 a 3 square minus 1/2 a 2 square. It's very clear. How you have been adopted this expression, just you have to take that. Distance travelled by the particle in the third second is equal to distance travelled in, total distance travelled in the 3 seconds, total distance travelled in the 2 seconds. They are going to be having their subtraction, just you have to take that. This is going to be in the third second. Total distance travelled in 3 seconds is going to be considered, and you have to subtract that distance travelled in 2 seconds. It's very clear. Now you can confirm it's going to be 1/2 a into 9 minus 1/2 a into 4. You will confirm that 1/2 5a. So this is the first equation. Let's distance travelled, it's going to be d3. Let's assume you have to take this one. Now you are going to get this, yeah, a is equal to a is equal to 4/3 meter per second square. It's very clear. Now you can easily find out this one. D3 is equal to 1/2 into 5 into 4/3. It's very clear. You can have the substitution and the calculations, just that 10/3 meter. Yes, you have to take that. Yes. Yes, that is in meter, all right, it's very clear. Right, therefore, D3 is equal to 1/2 5a meter, all right, it's very clear. So, we know that a is equal to 4/3 meter per second square, it's very clear. Just you have to take, this is going to be meter per second. Yeah, ignore about that units. Have the substitution and get that answer, it's very clear. So d3 is equal to 1 by 2 5 into 4 by 3. You are going to get that 20 by 6, that is going to be 10 by 3 meter. After getting that cancellation, just you have to take that. All right, it's very clear. Okay, now we would like to go for this one. If you are going to get all these, we can get that second square. It's going to be cancelled. It's very clear. Yeah, you have taken this one. This is 1 by 2a t square. So you will get that. This is the right. You have to take this one. You can write down that units, and after getting all the calculations, you can have that. It's better for you. Okay. In this method, we will find out the distance traveled by a particle in 4th second or 5th second or whatever it may be, if you are going to get that uniform motion, and it is going to be identified that there exists a linear motion. Right. Let's go for another problem. Yes, you have to take this one. It's very clear. Okay, have you seen that it is going to be identified that? Yes. Yeah, generally we are going to talk about that motion along one dimension. You have to confirm. We would like to get that x-axis, motion along the x-axis. It's very clear. Okay, you are going to get this one. If it is going to have the displacement along the x-axis, all right. Now, as the time increases, what about that? Does it changes? Yeah, you have to take this one. Yes, you have to take this one. Displacement is going to be along the direction. It's very clear. Now, we would like to go for the direction. It's very clear. In this direction, it has been moved. All right. Okay. And you are going to get this important observation. Yes, you would like to go for this. Yeah, t is going to be time. All right. So you can take that displacement is going to be the x meters or centimeters. Let's assume. Okay, as the time increases, what happened? It's going to be increases. Distance or displacement, they are going to be increases in case of the 1D motion. It's very clear. Its direction is going to be restricted along one direction. It's very clear. Okay, I am going to get that. What is the relation? Yes, x is the x is the function of time, or you agree? X is the function of time. It's very clear. You would like to go for this one. All right. Why we are going to consider x is the displacement or distance or the function of time? It's very clear. As the time increases, what happened? It is going to change its value. When you are going to frame the relation between the two parameters, which is going to depend on another. Now you can frame the relation between x and t. Is it clear? As the time increases, what happened? X is also going to change. All right. I am going to get that relation, that is x is the function of time t. All right, it's very clear. I would like to represent x is equal to at plus bt square plus ct cube. All right, in this way I am going to get that. What about a, b and c are constants? All right, it's very clear. We would like to identify that. Okay, if you are going to get that position of a particle, just it is going to be represented as a function of this time. It's very clear. As the time increases, it will changes its position in case of the motion. It's very clear. Now you are going to get that its displacement is going to be represented with the function of time. All right. Yes, you have to take this one. This is very clear. You would like to go for this. Okay. If you are getting that, yes, yeah, d by, just you have to talk about that different parameters. You can get that if v changes, then there exists a acceleration. An acceleration. Is it clear? If you are going to get that, the speed is going to change. What happened? There exists acceleration. All right, it's very clear. Okay. You can confirm that the speed is going to be maximum. After the maximum value, there is no change in its speed. All right, it's very clear. The rate of change is going to be, how do you say that it is maximum? There is no change. There is no change with respect to the time. It's very clear. That's going to be the maximum speed. All right. So it's very clear. If v is maximum, what can you write? D by dt of it's equal to 0. I think so. This is new for you. If you know, if you have been having any idea about this one, you can understood that matter easily. Yeah. Okay. That rate of change of v, rate of change of v. All right. Rate of change of v is going to be represented as d by dt of v. Suppose if you are going to get that, if the position is going to change that, the position of a particle can be described as x is equal to at plus b. It's very clear. So if there exists a change, that is going to be dt by dx. Yes, you have to confirm this is going to be v. All right. No need to consider all these points. Just you have to consider it's going to be having that maximum speed when it is going to be maximum. Yes, if you are going to look into that matter, if v changes, then there exists acceleration. All right, okay. V is maximum, then what happened? There is no change. If you are going to get that, it is, when do you say that it is maximum? After that maximum value, after that particular point, there is no change. Yeah, it's very clear. It remains constant. It was maintaining the same. There is no change. Just we have to represent the change, that is going to be d by dt of v. It's very clear. All right, everyone has to remember this one. In entrance examination, so you are supposed to answer these type of the questions which are given that. So it is very clear, they have given in this way. Yeah, you will find out that velocity is equal to d by dt of x. It's very clear. Yes, that's going to be identified. Yes, it's very clear. You have to take this one. This is very, very important. Yes, x is the function of time. X is the function of time. All right, it's very clear. Just have the look into that matter. You are supposed to identify that. Everyone has to get that. Everybody has to look into that matter. Then we will analyze that problem. All right. Yes, if you are going to see that, What is the relation? X is the function of time. All right, we have taken that in case of a 1D motion, just we have to remember. Yes, A, B, C are the constant. X can be represented as a function of time. It's very clear. X is equal to AT plus BT square plus CT cube. Just we are going to take that. A, B, C are constant. It's very clear. We would like to go for this one. If V changes, then there exists an acceleration. All right, it's very clear. If V is maximum, then dV by dt is going to be 0. The rate of change of V is going to be 0. Yeah, there is no, it's very clear. We would like to get this one. All right. So if you know that there is one relation regarding to that displacement or the distance covered by the body has been expressed in terms of time, then you can easily find out that speed and velocity easily you can carry on. Let's have the look into that problem. Yeah. Yes, you have to take this one. The position of a particle with respect to the time along x-axis. You have to take this one. It's very clear. Right. You have to take the position of a particle. It's very clear. They have given along x-axis. What will be the position of particle when it achieve a maximum speed along the x direction? Yes. Okay. What will be the position of? Very good question. Please have the look into the given question. Very simple. As we have discussed that the position of a particle, it's going to be represented with respect to the time. All right, it's very clear. Along x-axis in case of 1D motion. All right. Where x is in meters and they have given the function of time. X can be represented as x is equal to 9t square minus t cube. It's very clear. Either that, please ignore about the sign, whether we have taken the positive or negative. Okay, that depends on the value, that depends on the result, final result. Okay. We have to take that. What will be the position? Yes, we have to take the consideration of the maximum speed. It's very clear. Yes, you have to confirm that. What will be the position of the particle when it achieves the maximum speed? All right, it's get easy for you. All right, just we would like to go for this one, all of you. We would like to go for this one along the one direction. It's very clear. Yes, if you are going to get this one along, this is going to be x-axis. All right. Very clear. You have to confirm that it's going to be moving in this direction. If it has been traveled here up to this extent, here V is maximum. Yes, at this point, at t seconds V is maximum. Here it is initially at rest position, let us assume. Okay, it is going to be. So, yes, it is going to be identified that this is the, you have to calculate that position of the particle, which is going to be something we would like to take that. It's going to be x meter. Yes. Okay, let us take that x meter, let's assume. Very clear. We would like to find out that value. It was confirmed V is maximum. All right. Okay. When V is maximum means what we have discussed about that maximum condition. So, if you have taken that one parameter which is going to be maximum, but there is no change with respect to the time, then you have to say it is going to be maximum. All right. Okay. They have given x is equal to 9t square. It is represented in the form of one function, that is x is represented as the function of time t, it's very clear. Now you have to get that rate of change of position, you have to take that. Yeah, v is maximum means immediately you have to write down here, it's very clear, no change. Yes, you have to represent in the form of, that is d by dt of v is equal to 0. Simply you have to remember this one, the maximum condition. All the people has to remember, even though in the further classes you are supposed to remember this one, when one physical quantity which is going to become maximum, then there is no change with respect to the time. That was represented as d by dt of v is equal to 0. It's very clear. Alright, let's go for that problem solvation. Okay, we would like to start from this one, x which has been written, x is equal to 9t square minus t cube. Alright. Okay, rate of change of position. We have to take that first differentiation is going to be 0. It's going to be getting that rate of, here it is going to be is equal to velocity. Yes, you have to get that. We would like to go for this one. Alright. So you have to take that d by dt of x is equal to velocity. Alright, you can easily understand that matter, that is going to be v. Yes, we would like to find out this velocity. Alright, that is d by, it's going to be having the concept of the differentiation. If you are going to get that one parameter is going to change with respect to the time, we have to take that rate of change. Alright, that is going to be 9t square minus t cube. Alright, it's very clear, we would like to get this one. That is d by dt of 9t square minus d by, you are going to extend this one, t cube. The general notation, that is, if we are going to get that d by dt of t power n is equal to n into t power n minus 1. By knowing this formula, just you can solve that. This is very important, please note that. Here what we would like to write down, yeah, it's very clear, that's going to be 18t, let us assume it's going to be v, minus 3t square. Yes, v is maximum. What happened? You have to take this one, v is maximum, that implies d by dt of v is equal to 0. Alright, it's going to be identified. You have to be verified that. Yes, you have to take that. This is very clear. That is d by dt of 18t minus 3t square is equal to 0. It's very clear, we would like to go for this one. Just once again you have to observe this one, what we have been represented, the rate of change of velocity is going to be d by dt of x. It is very clear. After finding that velocity, we have to take that, we have to verify the condition, that is when the speed is maximum, you have to take that d by dt of v is equal to 0. Alright, we would like to verify this one. Okay? Okay. Yes, we would like to erase some part. Yes. Yes, you have to write down, that is equal to d by dt of 18t minus d by dt of 3t square is equal to 0. It's very clear. Therefore, 18 minus 60 is equal to 0. So, 18 is equal to 60, t is equal to 3 seconds. Yes, we have that one information regarding to that maximum speed. Yes, at 3 is equal to t 3 seconds, its speed is going to be maximum. Alright, it's very clear, we would like to go for this one. Alright. Okay, Yes, t is equal to 3 seconds. As t increases, what happened? The position of the particle is going to be changes. It's very clear, we would like to go for this. At 3 seconds, its speed. If you know the time, you can easily find out that position. Write down. That is going to be x is equal to 9 into 3 square minus 3 cube. It's very clear, 9 into 9 minus 27. That is 81 minus 27. You will get the answer. Yes, that is going to be 54 meter. Yes, finally at 54 meter, its speed is going to be maximum. Yes, this problem has been solved. Let's check the answer. It is going to be the answer. All right. So in this way we can solve the problems, many problems, whatever they have been represented with the help of the time. Okay, let's go for another one. Yes, it's very clear, we would like to go for that. Yes, yeah. Here also you can confirm that position is going to be changed with respect to the time. All right. Here you would like to confirm that is going to be distance travelled. Yes, and it is going to be S is equal to ut plus half at square. Very clear. Initially it is going to be identified V minus U by T is equal to A. These are also questions. You can easily identify these problems by applying the two formulas. All right, let's see that its position has been changed. Yeah, it's going to be identified. Now you can confirm. Yeah, if you know, does it has been started from that rest, you have to take that U is equal to 0. If it starts from started, yeah, yes, from rest you have to take that U is equal to 0. All right, we would like to solve. Okay, let's see that problem. Yes, a motorbike initially moving at 18 km per hour. All right, accelerate at rate of 5 meter per second for 5 seconds. Okay, the distance covered by it from start and the final velocity, you have to find out that. So they have given speed, yes, 18 km per hour, and the rate acceleration, that's going to be having value. All right, it's very clear. Time they have given and initial velocity they have given. Yes, you can solve the problem. That is going to be S is equal to yes, you have to take that 5, just you have to take that 18 km per hour. Yeah, we would like to solve this problem. Yeah, yes, you will get that 18 into 5 by 18, that's going to be 5 meter per second. Yes, it's going to be taken for 5 plus 1 by 2, it's also going to be 5 square. It's very clear. 25 plus 1 by 2, 5 into 25. 125 plus 125. It's going to be by 2. That is going to be 62.5. It's going to be very clear. So you have to take that. That is going to be 87.5 meter. Later you will find out easily. All right. So in this given problem, you can easily find out that. Yes, all the students, you can easily find out that this is going to be the final velocity. Yeah, V minus U by A is equal to T. All right, easily you will find out that V is equal to U plus AT. After substituting all these things, you can follow this. that is 5 plus 5 into 5, that is going to be 5 plus 25, 30. All right, this is correct answer. Okay students, thank you very much, have a nice day. We would like to go for that more number of examples and animated videos in the coming classes. Please keep watching.